Welcome to 115th episodes of this channel. So please subscribe this channel so you can access all those 100 plus videos on YouTube anytime, anywhere. So you don't have to search for a particular topic. So there's 115 videos so far. Covers a lot of calculus, vectors, and also trigonometry questions. So please subscribe channel to take advantage of accessing all the videos if you haven't done so. All right, today we're going to explore the question 10 of 2023 VCE Specialist Math Exam Paper 1. So this question consists of several questions. I'm going to do three of them. B, C, D. All right, so first one, I'm going to revise some of the formulas we're going to use. The first one is called Pythagorean identity. Sine squared plus cosine squared equal to 1. Second one, I'm going to revise called double angle identity. Cosine double angle is 1 minus 2 sine squared theta. So therefore, sine squared can be rewritten as half times by bracket 1 minus cosine double angle. Third one, I'm going to revise the sine double angle identity. So today we've got three very important formula to use, the trigonometry identities. Okay, so let's do the question A. So first, we need to convert this position vector in parametric. So this is the xt, and it's the y component. So we're going to rewrite it into parametric function. So xt is that. So we're going to convert it to Cartesian equation. So we know when we convert to Cartesian, we need to use t as parameter. So first things I'm going to use in the double angle identity to change the sine squared to a 1 minus cosine 2 theta and also times by half. So they end up with the equation number 1. So that's the xt. Yt, we're using a sine double angle formula. So 6 become 2 times by 3. So they end up with second equation. So that's the yt. So I'm going to change cosine t to x minus 2 divided by 3. Sine 2t is y take a 1 divided by 3. Then you're using the Pythagorean identity to get the formula of x minus 2 to the power of 2 plus y minus 1 to the power of 2 is 9. So we proved that was correct. So QUD is correct. Okay. So now we're going to do question C to find the particle from A to B from T, so T1, so that's a T1 to T2. A is unknown. Where to end, we don't know. However, we know the distance traveled along the curve A to B is that. So very important. So distance traveled along the curve. So we call curve length. Now curve length formula is using from A to B, whatever A is the AB is the T is the from that interval, A to B. Now this is different to this A, all right? This is the formula. How do we prove that? I'll just briefly look at the curve. If you look at the curve, it's got rise over run. So we got rise over run. So become then the hypotenuse, which is the arc length, approximately equal to square root of dx. So that length is dx, that one's dy, because it's change of x, divided by change of y, and then the square root of x squared plus y squared, so dx squared plus y squared. That's a Pythagorean theorem. So therefore, this formula is from A to B. So this is from A to B. So we integrate from A to B to get that. Now, in this case, dx is d derivative x with respect to time, which is parametric equation. So derivative y with respect to time. So time from the t from at the moment, t from 0. So in this question is from 0 to A. So we substitute dx dt, which is our derivative two functions. We will get that. Previous step, which is question B, we got derivative y with respect to time is 6 times by cosine square 2t squared. Then you take a 6 out and you move 6 to the outside. So the answer will be inside of square root is 1. So we know 1, when you divide 1, you just 6a. So because the arc length, this curve length is already given, so 6a equal to 3 pi over 4, so a is pi over 8. So we solve that. So that's a pretty interesting question, C. The next question is called perpendicular vectors. So we got two vectors. One is the velocity vector, and the other one is a position vector. So we just do the velocity vector is derivative x components, which is that, times by derivative y component. So I'm going to list it as a column vector form. Then the position vector are using the original vector. So when you, now this is the very important theory, if two vectors perpendicular, they dot product, which is a scalar product, must be equal to 0. So a scalar product, we know scalar product is x component times by x component plus y component times by y component equal to 0. They're expanding the brackets. We got negative 18, positive 18 cancel it out. So the end up we got 12 equal to negative 6, negative 12 sine 2t equal to negative cosine 2t. Then we rearranging the formula. Sine divided by cosine is half, become 10 is half. So we're going to do the inverse. So we're going to solve for trigonometry equations. So inverse of half plus the k times pi, which is rotating 180 or period. So just repeat it. The period is 0 to pi. So therefore the t is half of that. So what's the k? K is the natural number, but also including 0. So k can be 0, start with 0. So that's it. We solve the t. So because the question said what is the value for t? So the value for t is this. So that's t. All right. So this question is very good. Range the mathematical knowledge we need to use. We need to use the parametric functions. We also need to find the derivative parametric function. Also, you need to use the trigonometry identities, and also you need to use the arc length or curve length, and plus the perpendicular vectors. Thanks for watching. If you like the video, please give us the thumbs up and continue to support the community of this channel. I'll see you next time. Bye.